This video is about hacking a KillAWatt to make it transmit the data wirelessly to a remote computer where you can graph the data or store it for later analysis. And what I did initially was I started with a KillAWatt kit from Adafruit.com. It looks very similar to this. It has some extra parts. And what you do with that, you install it inside a KillAWatt, and it reads from an op amp the current and voltage and transmits the data every 2 seconds or so to a receiver. And actually, in my case, the KillAWatt did not work very well at all. And what would happen is, after about a minute, the screen would flicker, and shortly after it would just go blank and it would stop transmitting altogether. So what I did was I tried to salvage the situation by making my own alternative solution, KillAWatt, and it's based on a Arduino clone which I designed for my own needs. And what it is a Arduino that runs at 16 megahertz, and it has a transceiver on the bottom, and this is the antenna for that transceiver. And what it does is just samples current and voltage that go through a voltage divider to bring it down to 3.3 volts, and power comes from the KillAWatt, and it goes through a Schottky diode, and there's also this capacitor that helps stabilize the circuit, and then this LED which will just show, it'll blink every second or every transmit cycle. And what's more special about this circuit is that it's very low power. The sketch that's running on the Arduino is sleeping most of the time. It just wakes up once a second or once per transmit cycle, and it samples data from the voltage and current and transmits it, and then goes back to sleep. And then this is the receiver end of it. It's the same node, and it has the radio on the bottom. You can see it here. It's an RFM12B running at 434 megahertz, and it feeds through a FTDI adapter into my computer. And on my computer I have this Python script which I adapted from Adafruit's version to read the data from the serial port and graph the power and the waveforms for current and voltage. And I also added an enhancement to the script to transmit the data to my Raspberry Pi, which is running this Emon CMS platform. Emon CMS is also another way to store data and visualize it in nice looking graphs. And you can see how I'm transmitting power to Emon CMS, and here's the graph from Emon CMS looking pretty much the same as the graph that comes directly from Python. And right now I have this fixture that I'm using to test this setup. It's only feeding this 60-watt bulb right now, which is reading 61 watts on the KillAWatt and 61 watts, or around 60, on my computer. So let's see what happens if I screw in another bulb here. It's 100 watts extra. So now we read 163 watts. It's reading 164 in Python. And you can see how it spikes up immediately. And you can see the same thing happening here in Emon CMS. So this is my solution, or my alternative solution, to a KillAWatt that was not working very well. And anybody can replicate this with a Arduino clone and any kind of radio. But this circuit is very simple, it's very cheap also. The radio only costs around $6 or $7 online. So you can build this yourself if you're having problems with the KillAWatt, or want to save a couple bucks. Because the KillAWatt, I think, I don't know, costs like 30 bucks or something like that, plus the radio. So it'll cost you around $50, and I'm just assuming here, so don't take my word for it, but around $50 to make a wireless KillAWatt using the Zigbee solution from Adafruit. And I'm gonna post the schematic and code on my website hopefully soon to make this available to anyone who's having similar problems or just wants to build this alternative solution. And thanks for watching, and stay tuned for updates.